In our last lecture, we had talked about GDP or national income. And we talked a little bit about how money can complicate things. As I said, if you make $1 million a year, that's probably a lot of money, unless the average income is $1 million and $1 million can buy you a loaf of bread. Inflation, by definition, is an increase in prices. The higher prices get, the more it complicates things. If prices rise really fast and we measure how much we're producing in terms of current dollars, it might seem like we're doing very well in the case of the $1 million pizza example. So how do we correct for that? Is there a way to correct for that? And what even is inflation and how do we even measure it? These are questions that we're going to talk about right now. So just a reminder, money is relative. $1 million in a duffel bag in the middle of the woods is still going to keep you lost. We need to tame for money, we need to account for money, and we need to be able to correct for changes in the value. So a few reasons why inflation is important and measuring inflation is because, well, we need to sometimes know the cost of living. We also want to know, are our real wages going up or down? Not our nominal wages. We know that. Every time your boss gives you a raise, say your boss gives you a $5,000 a year raise, we know that that feels like $5,000. But let me ask you this question. If $5,000 raise represents, I don't know, a 10% increase in your income, what happens if inflation raises by 20%? You see, nominally your wage is going up, but in real terms your wage is going down. Even though you're making more money nominally, you're able to buy fewer goods and services. And remember, economists care about the goods and services. Money itself is just a arbitrary, temporary store of value. We also want to care about the value of our currency relative to other currencies. So with that, we care about the exchange rate. By the way, you should be noticing something. Whenever economists talk about real variables, we're talking about variables that are adjusted for inflation or corrected for inflation. Let's see how they do that. First, we need a price reference. Now, we do that by an index, and this is how we're going to correct for prices. We're going to correct for prices by using the same prices year by year. And from that, you can see how the prices change relative to that base year. This is the power of mathematical indexes, and I strongly recommend that you learn more about just the value of mathematical indexes. They're very, very easy to work with. I will teach you how we use the CPI or the index used for changes in prices. But indexes themselves are amazing tools that we can use to compare apples to apples when the variables change. So we get an estimate for a bundle of goods and services, and we keep that, and we see how much they change from year. We designate a base year. Now the base year, the beautiful thing about indexes is that it doesn't matter, mathematically speaking, what base year we use. What's important is we need to use the same base year for every single year. That's how the index works. So there's a lot going on in the slide, but basically, in order to calculate the consumer price index, which you may have heard in the news, but the consumer price index is the estimate of the price level. And the way it works is that the CPI is the price value of a basket of goods and services this year over the same bundle of goods and services in the base year. When you take that change and you multiply it by 100, because it will be, there's kind of a percentage now, you get the index. And the index will represent, if it's above 100, it means that there's going to be a growth in prices. Below 100 means there's a decline in prices. So I made this simple example, and I used a couple of random years from a while ago, and I should probably update the years, but the math works either way, so I never decided to upgrade the years. Anyway, um, so we have a random collection of goods and services, and by the way, this is exactly how economists will do this. They'll take a collection of food, clothes, housing, get the same number. Remember, we need to adjust for prices now, so get the same number of each, see how the prices change, and you'll get the change in prices. Now, before we even get to the inflation rate, which is the final piece of the puzzle, what we need to do is we need to say, hey, we have these change in prices from year to year. We know that they're changing in prices because every year is compared to a base year that's staying the same. What's the percent change of this price level from year to year? And that brings me to the percent rate of change formula, which, by the way, of everything I can teach you, I highly recommend that you learn the percent change formula. I use this in my own life for tracking trends, whether investments or loans pay down, or if you're a runner and you want to track your progress from month to month and see your percent decline or improvement, is an amazing tool to use in your own life. So I'll teach this to you and then relate how we use this to calculate inflation. And the percent rate of change, and this is going to be, you could use this for anything. I'm using it in the context of CPI. You can use this for anything. It's the, excuse me for a second. I might actually keep that in the video because I'm kind of on a roll here. Anyway, sorry about that. So, percent change formula is the new value minus the old value over the old value times 100. In this case, we're looking at CPI. So it's the new CPI minus the old CPI divided by the old CPI times 100. And here's a mathematical example. And if the CPI this year is 108, last year 105, divided by the original 105, we get the percent change of 2.9%. This is the inflation rate. So anytime you hear the inflation rate, think of the percent change in the price level, and the price level itself is estimated at CPI. So some scenarios. Let's talk about real wages, and we'll talk about measuring GDP. These are two areas where where inflation and CPI come in really handy to help our economic analysis. So real income, very, very easy to do. And what you want to do is you want to measure your real income year to year using that year's CPI. So if you want to compare your annual income this year, 2024, or whatever year yet you're watching this video, and it's compared to last year, which at this time it would be 2023, then what you do is you take your income and divide it by the current year CPI and times it by 100, and you'll get your real income. So a very simple example is if you're making $45,000 this year and CPI is 105, then your real income is $42,857. Now let's say you're making more money, but there's a much higher CPI. Could your real income next year be less than $42,857? In fact, it could. If inflation is moving faster than your wages, then you are actually losing money. Again, you're able to buy fewer goods and services. So CPI is very useful for determining real wages. And I would encourage you, by the way, to do this if you're ever talking to your boss about getting a pay raise. Know the inflation rate, know how much you're worth, and you can use this to justify more money. Very powerful stuff here. Now, lastly, we need to talk about GDP. Now, GDP, as you know, if prices are increasing by 25%, it might look like we're producing 25% more stuff. But we're not. It's the prices that are going up by 25%. So we need to correct for inflation. And what we do is we could use the CPI to calculate what's called the GDP deflator. And to calculate real GDP, it's very, very simple. You take the nominal GDP, divide it by the GDP deflator, and you get real GDP. And I got even better news for you. You don't need to calculate GDP deflator. It's always going to be assumed to be given to you in any exam that you have with me. Why? Because economists do a great job of actually telling you what the GDP deflator is every year. So that's even less work for you to have to worry about. So I hope that you enjoyed the lesson on inflation and CPI. Remember, CPI measures the price level. It compares the prices today with the price of a base year. By doing that, we can compare prices every single year. Because the prices this year, prices last year, the price next year, all three are compared to a base year. So we can actually see the changes in the price of all 3 years compared to each other. That's the value of indexes. We use the percent change formula to actually give us the rate of change, up or down, of the price level, so we can see if prices themselves are going up, coming down. Very powerful stuff.